What's up, YouTube? As I was saying, what's up, YouTube? It's your boy Professor McCullough here, and I am in Greensboro, North Carolina, home of North Carolina A&T State University, where I got my master's degree in biomedical engineering. So shout out to them. Shout out to the Aggies. Now today I'm going to talk to you guys about something particularly important. You know, it's super hot out here, and I need some water, so I'm going to talk to you guys about some water. And by the way, it really perplexes me why some people don't believe in global warming. It is too hot out here, okay? But I'm gonna tell you guys some of the things that make water biologically important. So good old H2O. All right, so water has these two properties, which makes it very important. It makes it different than other liquids, okay? So water is what we call adhesive, which means it sticks to other things. And it's also cohesive, which means it likes to stick to itself, okay? So if you take a bucket of water and you pour it on the wall, all of the water isn't going to roll off of the wall, some of it will stick. And see, that's actually biologically important, because if you take plants, for example, especially trees have these roots that dig into the earth and they take up the water. And so that pressure that is caused by the take up of that water is going to allow the water to be placed into these vessels called xylem and phloem. And basically what happens is that the water stacks on top of itself and the sides of the vessels, and eventually the water is going to make its way all the way up the tree trunk and then into the leaves and the other parts of the plant. Another thing very important about water is that it freezes from the top down, and that's super important. Like, imagine if water didn't freeze from the top down, then how would things like the Arctic and Antarctic, how would it even exist? Because that's what caused the ice to flow on top of the water, because water is a special compound where the solid form, which is ice, actually is less dense than the liquid form. Another example is when, let's say you have a lake and it's the freezing season over the lake. If water froze from the bottom, then that means all the soil and plants that gives the ecosystem is very rich oxygen and different bacteria and everything that the fish need to survive will actually be killed, because the water has froze from the bottom. But it freezes from the top, which allows the swimming of fish. It allows them to swim around freely, and it also allows ice fishing, which is when they they actually put a circle in the ice and then put a fishing rod down there and then they fish. So how could that be possible if water froze? So, y'all, I'm by the airport, so I'm so tired of these airplanes. But yeah. So it allows people that live in those Arctic climates to actually eat, because they can still fish because the water has froze from the top. The next thing you need to know about water, or how it helps us live, is that it has a very high specific heat capacity, which means it takes a lot of energy to change the temperature of the water by 1 degree Celsius. All right, and that's important because our bodies are 70% water, and so we need to maintain homeostasis. We need to maintain a constant environment, especially when it comes to our temperature, okay? So I was teaching one day, and one of my students asked me, "Professor, what do you think about water being wet?" Well, I'm one of those people that believe water is wet without a shadow of a doubt. And that's because the definition of being wet is being surrounded by a liquid. So if you have one water molecule, that means that it's other water molecules which are in liquid form surrounded that one water molecule. So indeed, water is wet. So that's a little bit about, you know, why water is so important. So I hope you guys, if you guys have any questions, please leave them in the comments. Make sure you comment and subscribe to me, Professor McCullough, and I hope to see y'all next week for another video.